Bismillahirrahmanirrahim. There were a lot of requests for Z-transform questions. I've already done example 10.1 and 10.2, and today we'll be solving example 10.3, and this is from the Signals and Systems, chapter number 10. So this is the question. Let us consider a signal that is sum of two real components. So this is one component and this is another component. Now we know this formula for Z transform, that any signal with that we multiply Z power minus N to convert it into Z domain. So in our case, instead of Xn, we'll place this signal here, rest everything remains same. And then we multiply individually with Zn. These are two separate terms now. And Zn can be added with 1 over 3. So it will be 1 over 3 Z minus 1, and then we take N common because there is an N here and there is an N here. So we take N common. Also, since this is U and that means it is starting from 0. So this limit will now be, instead of from minus to plus infinity, it will be from 0 to plus infinity. And same here, same technique. So now these are the two signals, and we have already learned that if x or the mod of x is less than 1, then the summation xn can be written as 1 over 1 minus x. This I have explained in the previous two videos. We will follow this formula here. This is our x in this case, and this is x in the second case. So we can write 7 divided by 1 minus x. Now this is x. In this case, it will be 6 divided by 1 minus, this is our x. And the condition as it is given here, the condition is that the x or the mod of this value should be less than 1, and similarly the other one also should be less than 1. And now if we take or try to subtract both of them, so the LCMs, 7 multiplied by this one and 6 multiplied by this. I hope you know this. Simplifying, opening the terms and solving, we get this answer. Now I've separately just done for myself that like 7 and minus 6 will be 1, this one, and then 7.5 and 613, which is 613 is actually 2, so it will be minus 3 by 2, so minus 3 by 2. Now to plot, we have learned already in example 10.1 that for ZA greater than 1, the ROC will be a circle at greater than A, sorry. ROC will be a circle with the radius A, and it will be outside that radius. It will, because it has to be greater than the A. So A could be anywhere, here, here, here. So ROC is outside. Same here. And just to simplify, we could also take the right Z minus 1 as 1 over Z, and then you can solve. But I think the simplest way is to multiply by Z square. One Z will eliminate this one, the other one here, and similarly both numerator and denominator. So at the numerator, this will be the extra Z, and this multiplied by z will give z minus 3 by 2. And similarly here, z and this z and z minus 1 will get cancelled, so it will be 1 over 3. So this is the relation, and now it is like this. We will focus on the denominator because that is what causes the pole. So for convergence of xz, this one has to be greater than 0. That means mod of z has to be greater than 1 over 3. And for the second case, mod of z has to be greater than 1 over 2. Now let's see them graphically. First one, we draw a circle of radius 1 over 3, and this is the pole at this. So our ROC will be above this, out of this circle for the first case. And for the second case, it will be similar, except that the circle will now be of 1 over 2. And so which one do we take for the combined? Because if we take this one, then 1 over half or the pole will be here somewhere, and we cannot have a pole in the ROC. Therefore, we have to accept this for both, where the first pole is inside the second pole, and they are both inside the ROC. Therefore, we will say that the region of convergence for this signal is mod of z has to be greater than 1 over 2. That is, this is the cycle. So I hope you have been able to follow this simple question. Please comment. Thank you.